here we go. So we got the 1x1 square plate, and it has a mass of 30 kilograms. Alright, and it's supported at an angle of 20 degrees, and it's above the horizontal X and Y, and it's supported by this hinge right here. So basically what that means, these are going to have supportive forces, AZ, AY, and AX, right? And same thing here, this is going to have a support force going BZ, and this is BY, and then it's going to have BX, right? And it's being supported at 20 degrees above. So basically, if we viewed it from the side, it would look something like this. Like, I'm just going to draw the Z and X planes. Oh, Jesus. Still can't draw. Right? This is X, that's Z, right? So it's just going to look something like that. 20 degrees. And it's 1 meter long, right? So we actually going to have to find out this distance here, this distance here. So we know where point C is, right? Simple stuff. Easy. Okay. And the first thing what I'm going to do is, you see this, I'm going to make that in terms of IJK format. I'm going to find the unit vector of this so I can use it in future problems. Alright, and so I can put it in terms of T, and then I can use that and later on for moments, as you will see. So, alright, well, first things first. First things first, we're going to find point C, right? Which is basically just going to be 1 times sine of 20 and 1 times cosine of 20. Gets me sine of 20, gets me the Z value, right? Which is going to be minus 0.432. We'll put in K hat. And then it's going to be 0.9397. That's good I hat, right? So really, like, this point here is really 0.9397 0 0.342, right? And then we already have point D, so really just finding that, it's pretty easy because that's just the points of D minus the points of C. So in this case, it would be that 0. That would be that 0 minus that, right? Yeah, that looks gross. Okay. Okay. It just looks weird on the graph. No, it's just wondering. Alright, so that's going to be that negative 0.397i, and then that's 1.2. J, and then which one? Ah, no. What am I saying? B 0.658. Okay, right? So that's the vector from here to here, right? And when we do the unit vector, the magnitude of it, just find the magnitude, or CD, is just 1.66. We'll put in meters, and then unit vector is going to be equal, which, you know how to solve for unit vector, you just take each one of these and then divide it by this. That's all. So it would be 0.56i plus 0.723j, and then plus 0.396. Okay. Now what this allows you to do, if I multiply by this by any magnitude, I could find the forces in the x and the y and the z. So like the tension force is actually, we can actually make it so tension is going to equal to that negative 0.566 t x I plus that 0.733 ty j, then plus that 0.396 t z k, right? Just gonna, right? And boom, we have the unit vector for TCD. Really simple, really easy. And then if we, for the weight, we can get the vector for that. Weight would just be, yeah, be 0i. It's just only, it's weighing it down, so it's only in the k direction. So 0j, then minus 30, it would be 30 times 9.81, right, which is 294.3 k, right, boom. Now, in the question, it states that b of y is equal to 0, right? So, the best way I can solve for my unknown forces as of right now is actually just going here. It's finding the moment about this, and all the directions, of course, it'll be like, it's going to be some moment of a equal to 0, right? In the vector format, right? Which gives me R AB crossed with R B, right? And then plus R AW crossed with W vector, and then plus R AC crossed with T C D vector. See where that comes into play? Boom, perfect. Now, the difficult part is this actually right here, right? But not really, because this point will be at this, the way you find W is it's going to be at the center of the square, right? So if we looked at it, if we just had the plate itself, if it was on a flat surface, the point would just be, 0.5, 0.5, right? Because this would be an actual point. But since we're at a 20 degree that changes where that point is, we're just going to forget about this, right? So basically, what you have to do is as you know, we found the x, right, and the z of this. It's really just half of that, right? It's really just half of that. So like that w, I'm gonna make it. Oops, you buy it bad. I'm gonna call it w, right? I'm gonna just put w here, and it's just really just you take that and just divide that by 2, which gives me. I'm sorry. 0.9397 divided by 2, which gives me 0.469, right, in the x direction. And then this would actually just be 0.5, because in the y it's still that 1 meter, right? Just that it's still 0.5 there. But then we actually have a z in there, right, which is 0.171, right? So this is what you call the center of gravity. And whenever you have a problem where it's like a plate or something you have to find, it's usually really simple to find, like this problem, or if it's a complex shape, it'll give it to you. But so basically, now we have that. We know where AB is, we know where A and B are, and we know where A is relative to W, and same thing here. So basically, now this is gonna be, I do the cross the IJK, right? And well, in the I direction, there's no change, right? So 0. In the J direction, there is a change, 0.68, because that's 0.16 meters away from the origin, and this one's going to be .84, which is so it'd be 0.84 minus 0.16, and gives you that. And then okay, not 0, right? So and then we do the x, right? Oh, 0, boom, perfect. And then we do bz, right? Plus, and you do it the same thing here. I, j, k. I'm gonna go ahead and just do this. Right. So here, again, it's just going to be what I found at the x up there. The j is a little bit changed, and the k is also what I found what w was. And I'm just going to go ahead and do this one right here. I is what I found there, right? Then negative 0.16 because it's the I, then 0.342, right? So, and for this, for the w, we have it. It's already solved for, right? And then that's negative 294.3, right? And then here, this is all in terms of t, right? 0. Negative 0.56 tx. I'm gonna lower arrows so I can tell what's what. I kind of made a little cramped. Ty, and then 0.396 tz. Alright? And if you didn't know how to do the cross product, I'll review real quick with this. It's basically what you do to find I, you do this times that, and then this times that, and minus them. So it'd be 0.68 bz minus 0 I, and then you actually subtract whatever you get for j. So j would be this cross with that, and then this cross with that. It'd just be 0. I'm gonna write 0 because as you can tell, it'd be 0, 0. And then k, this cross with this minus that cross with that, which would give me negative 0. Yeah, 68 this is going to be equivalent to 0.68 BZ in the I, and then minus 0.68 BX in the K. Okay. And now I'm just going to write it out for all the ones because I solved it pre-hand. So I don't have to like worry about all this. Put it. Okay. I see. Alright. Okay. There you go. So we got that, and then this. I'm gonna do it different colors. And this one, I'm gonna put right here. I'm just gonna put that plus. So all being plus. Anyways, and the only thing that's gonna survive here is the I and the J. So it would end up being minus 100.062 I plus 138.262 J. Right? Plus, I'll do the last one. Right? I'm gonna just do it over here. I'm gonna do plus. It's gonna be negative 0.3106 T in the I. Yeah. I made a mistake up here. It's just T because that's the magnitude. So do not do what I did. My bad. That would just be T. All this would just be T. That's my mistake. I did it right here, right then, right up there. God, kill myself. Alright. Then minus 0.5657 T and the J. And then plus 0.588 T and the K. Now I know this looks daunting, but like we do something real quick. Let me change the color of this. Oh, why not? Alright. Well, we're gonna do like terms. We have I here, right? And I here. No. But we only have 1, 2K. Right? Super simple. And then we have only 1, 2 J's. And look, we have that J. And we only have, and as you should know, that if we separate these, we do MA and the I, MA and the J, and MA and the K, right? And these would all equal 0, right? So really, we could solve for T right away because it's just that 138.262 minus 0.5657 T. So right away, we get T. We're going to get T equal to 244.409 newtons, right? Boom. Solved for. We solved for one of it. The reason that's important, if you look at all the other ones, oops, that's my bad. That's actually in the J. That's the same difference. I'm just gonna do this. Oops. Okay, just move this to the J column. Damn. Keep messing up. You know what? We're just gonna erase this. We're just gonna make that J. And this I. My bad. So now you got the 0.68 BZ, right? Equal, minus 100.062 and then minus 0.3106T. Alright, and then we get BZ equal 258.787 units. Because you just plug in that T. We solve it. It's awesome. Alright, and then K, you got the negative 0.68 BX, right? BX, and then we got just one more. Plus 0.588T, right? So then BX is going to equal 211.65 units. Alright, so we got 3 of the forces it asks us for, actually. So we got this, and we have this for actions at B, because BY is equal to 0. So now we just gotta find the ones at A, right? Which is really simple. All you gotta do now, as you know, doing problems in 3D, you have 6 functions to work with. The sum of forces and sum of momentum equals 0. Alright, so now we do sum of forces of X, sum of forces of Y, and then sum forces of Z equals 0, equals 0, equals 0. Alright, super simple. And in the X, you have tension, BX, and AX. And AX written and BX in the same direction. And then it'd be minus 0.566T. Right? And that's coming from this right here. And then since we know BX and T, we can just make AX. You can find AX equal to negative 73.310 units. And when you see a negative, that means that the AX, we drew it going, and we drew the AX coming in this direction. That just means it's really going this way. This means we're bad at guessing. We shouldn't guess too much sometimes, but whatever. And then this is just AY plus 0.723T. Again, it's going to give us another negative, which just means it's just going the opposite direction that we drew it. That's all. Gives us that nice number right there. And then in the Z, same as AZ, it's BZ, but this time we actually have to weight the 294.3 plus the 0.396T equals 0. Right? No, I already wrote that. I made that. So then AZ is going to equal negative 61.273. Like I said before, negative, all that means it's just going the opposite direction. That's it for this problem, actually. If you have any questions, put them in the comments. Thank you.